Polynomials. A polynomial is a finite expression with positive whole number indices. As an example for a polynomial, I can say 2x plus 4 or 4xy squared plus 3x minus 9 or an 8. 8 has the power 1, which is a positive power, positive index for the 8, or a 2x plus 4 has a positive powers and a finite number of terms. The same with 4xy squared plus 3x minus 9 has a finite number of terms and the positive indices, as you can see. However, square root of x is not a polynomial because the square root of x means x to the power of 1/2, where we said in the definition of the polynomial has to be positive whole number indices. That's positive but not a whole number. Over here, for the 6x to the power of -2, it's completely opposite to what we said. We said in a polynomial or an expression, let's say, in order to be a polynomial expression, supposed to be finite number of terms. It has a finite number of terms. However, it doesn't match with the positive whole number indices. It has a -1. Obviously, 4 divided by x, that's a rational fraction that can be written as 4 times x to the power of -1. As you can see, it does not have a positive indices. So we have here polynomials, not polynomials. You're not necessarily going to be asked to identify the polynomials or a non-polynomial in the A-Level exam, but it's better to know what is a polynomial, what is not a polynomial. Alright, so the main topic is going to be dividing the polynomials by the factors. By the linear polynomial, let's say, that can be a factor of the polynomial, cannot be the factor of polynomial. We can actually say whether it's a factor of the polynomial or not at the end of each division. Okay, so you can use a long division. The long division you know from grade 4 or grade 3 for the numbers. The same logic that we're going to be using for algebraic expressions to divide the polynomial by x plus or minus p, where p is constant. The x plus p or x minus p is also a polynomial. Basically what we do is divide a polynomial by a polynomial, or that divider it can be also in the form as ax plus b, like for example 2x plus 2 or 2x minus 5 is the case also here. Okay, so this two thing is possible. I'm going to be demonstrate those on the examples. We will be doing 3 or 4 examples, I forgot the numbers. Anyway, alright, so we are asked the first one, the easy one, to divide x cubed plus 2x squared minus 17x plus 6 by x minus 3. So you know from the grade 2 or 3 or 4 or 1, wherever you learn that's how we divide the polynomials by the expression. The numbers by the expression. So like a long division sign, I'm talking about this one over here. So under that I'm gonna write x cubed plus 2x squared minus 17x and plus 6, and the divider will be somewhere here as x minus 3. Okay, so when you start dividing the polynomial, the purpose here is to get rid of or cancel out the terms has a higher power than this polynomial. By the way, this polynomial has the power 1 as the x has the power 1, but this polynomial right now has the power 3. We are taking the leading term, which is x cubed, and we will be simplifying this and then one after until they have the term which has the power smaller than x minus 1. For example, 2 has the power 2x to the power of 0, which has this smaller power than x minus 3. Okay, so the first thing that I need to do, I have to get rid of this x cubed. So to get rid of x cubed, I'm going to multiplying the linear one, x minus 3, by x squared. So that the multiplier is going to be written on the top, x squared, and then it's going to be multiplied by x minus 3, and the expression is going to be written under the polynomial expression. It's going to be x cubed minus 3x squared. Just a quick reminder, we actually did this when we are dividing the numbers. It's nothing different. Let's imagine that I'm trying to divide 56 by 3, for example, right? So the way we divide this is we just looked at the 5 first. If there is a 3 inside that first integer or first digit, let's say, so we just, oh, there's a 3 over here 1 times, and then we just like, oh, that means 1 times 3 will be 3, and we are going to be writing it beneath the 5, and then we minus it, it's going to be 2, and then we break down this 6. The same thing we are actually doing right here with the x cubed plus 2x squared minus 17x plus 6. And what we say is, in the x cubed we have x minus 3 x squared times, and we multiply x squared by that, and we write it beneath the expression. So we are going to be minusing this expression from everything over here. Obviously this is not going to be subtract anything, there's nothing like to that, but x cubed we're going to minus x cubed, and 2x squared we're going to minus 3x squared, and then and so on. Okay, there's a minus in between. Be very careful when you are subtracting them. Remember, the plan was to get rid of x cubed. It's actually working because x cubed minus x cubed will be 0. You don't have to necessarily write it. And then 2x squared minus negative 3x squared. I'm going to write it only once, then later on I'm not going to be writing that, okay? So that's going to be plus 2x squared, and that's going to be minus negative 3x squared. Alright, the rest, negative 17x minus 0, because it doesn't have any like term, it's going to be minus 17x, and then the same for the 6, it's going to be staying there as it is. Okay, so we can now write this as a 5x squared minus 17x plus 6. Now I'm going to be doing the same, exactly the same process as I get rid of x cubed. Now I need to get rid of x squared that I have here because it has the power greater than x. So I need to do this until the expression has the power smaller than x minus 3, then the process is over. Okay, so how many times x minus 3, or let's say x we have in within x 5x squared, it's going to be a 5x times. And the positive, I'm taking it plus 1 over here as I take it over here, because I needed 5x squared beneath that. When I subtract it, it simplifies each other. Sometimes I'm going to taking this minus, it depends what sign I have over here. So right now this is positive, I take the positive one down. I need to take the positive one down there. Okay, so 5x multiplied by x minus 3 will give us a 5x squared minus 15x's. Be very careful with this process. Okay, so the like I'm gonna just do it directly. 5x squared minus 5x squared will be just a 0. I'm not gonna write it. And the negative 17x minus negative 15x, that's gonna give us negative 2x's, and then plus 6. So far so good. All I have to do right now is to identify how many x's we have in negative 2x, or negative 2x plus 6. We have it negative 2 times. It's going to be negative 2x and plus 6. And why did I take it negative? As I explained over here, I have to take it negative 2 over here, as when I multiply it by this expression, I will have a negative 2x's. When I subtract these two, that gives me 0, which I needed because the expression I'm going to have here has to be, it has to have a power is smaller than x minus 3. Okay, so when I subtract this, in fact, it's going to be 0, which means it is totally divisible by the polynomial expression x cubed plus 2x squared minus 17x plus 6 is completely divisible by x minus 3. You can say that x minus 3 is actually the factor of this expression. So I'm going to be writing this now. I'm going to be writing this f of x, or there's no f of x. Let me write this as like x cubed plus 2x squared, I believe, yes, minus 17x plus 6 is equals to x minus 3 multiplied by x squared plus 5x minus 2. Yes, so if I actually expand this, I'm going to be having this x cubed plus 2x squared minus 17x plus 6, which is the nice. Okay, so why do I need to write it? Let me just quickly go through on that. So sometimes I have a, let's say, a fraction over there that I just found a factor and I'm writing in this way. There will be a denominator to simplify the common factors. This kind of things, you might gonna see this when you're working on the past papers. Okay, so let's move on to the next example. This example is a little longer, no, actually, just the same. The previous one, we're asked to divide the polynomial by 2x plus 1, and then we need to write it something like this. We just did it on the top as well. Okay, let's just try to write this expression over here: x to the power of 4 minus 17x squared plus 4, and then that's divided by 2x plus 1. So all I'm going to do is I'm going to be multiplying this expression by 2x cubed. Okay, why 2x cubed is I need, when I multiply this by that expression, I should have an x to the power of 4. It's the only way we can get it. The only way we can get it x cubed times x, which is going to be x to the power of 4. And then also there is a 4 over here. Imagine I have a 3x cubed here, or x to the power of 4, I mean. And when I subtract them, there will be still x to the power of 4 remain. But I want to get rid of this. So what I do is 2 times 2 is 4, x cubed times x is x to the power of 4. So I'm more than happy because 4x to the power of 4 will cancel out each other. Okay, so a 4x to the power of 4 plus, there is a 1 times that as well, 2x cubed. Okay, so let's subtract it, and then when we subtract it, we are going to have negative, let me actually write it in this way. So negative 2x cubed minus 17x squared plus 4. Okay, guys, so this expression minus this expression is not going to give us anything because they're not a like term, right? So but that's going to make this negative. So I write this leading term in front of the expression just because, and the next step I'm going to be getting rid of this, so I need to know what do I need to get rid of first. Okay, if I write the x squared here, if I do this process, it might gonna cause a little more work or a confusion. Okay, so I always write the leading term, or a leading, the leading term is the best one. Leading term in front of the first one, like the in front of the expressions, like the comics first. Like that's why we call it the leading term. Okay, okay. So then what is next is, I need to get rid of negative 2x cubed. Okay, I need to get rid of negative 2x cubed, where I'm going to be multiplying it by just a simply x squared. Okay, I already have here 2, and I already have here x, so I need to multiply it by x squared to have x cubed. So I need to take this one negative. There's a negative over here. Okay, so that gives us negative 2x cubed, and don't forget to multiply by the other one. That's going to be negative x squared. So subtracted, there's always a subtraction over there, don't forget it. That will be negative 16x squared and plus 4. And the next step is to multiply it by 8x, and that's going to be negative 8x. So then by 8, because I have a 16, negative 16 over here, and by x because I have a x squared here. And when I multiply it by negative 8x, it's going to be negative 16x squared, and then that's going to be minus 8x. So finally that gives us 8x and plus 4. If you subtract it, just pause the video and think about it. And what I have to have now is to multiply everything by 4 in this expression to have 8x plus 4. Which is luckily going to work, and then 8x plus 4, and then that's 0. So so you can actually say that 2x plus 1 is a factor of this polynomial, is complete division. There is no remainder left, and like they said, now we can write it as they want. Okay, So at the end, I'm going to say the f of x is the same as 2x plus 1 multiplied by 2x cubed minus x squared minus 8x plus 4. Okay, so that's what they want. Okay, a, b, c, d are all there. A is 2, b is -1, and the c is -8, and d is 4. Alright, that's example 2. Now let's move on to the last example. Yes, it's the last example in this topic. Okay. So find the remainder. We called it also leftover when we divide like, for example, 28 divided by 3 gonna give us the remainder 1. So we need to find the remainder here also, because it's a long division anyway. When we're dividing it by x minus 4. Okay, so here's the thing. The process is exactly going to be the same. There will be nothing different. Okay, this little guy is playing with me now. Okay, don't touch it. Alright, so 2x cubed minus 5x minus 16x plus 10. Let's divide by x minus 4. Okay, so what I'm going to do is going to be multiplying it by the 2x squared. 2x squared times 2x will be 2x cubed. 2x squared times -4 will be a -8x squared. Okay. 2x squared times x will be 2x cubed. Alright, so double checking this. Okay, then start subtracting it. It's gonna be here 3x squared minus 16x plus 10. Okay, that's a 10, I believe. Yeah. Then what do? I'm gonna be multiplying it by the 3x's. That's gonna be a 3x squared and then minus 12x. All I have to do now is to subtract again. That's going to be this time minus 4x's plus 10. This time I'm going to be multiplying it by the 4, and that's a -4x's minus plus 16, and just subtract it again. The remainder will be -6. Okay, they say to find the remainder, so they're going to say that the remainder is -6. Okay, so we need to divide this polynomial. So x minus 4 isn't factor of the polynomial expression. Okay, so there's a leftover. In the next lesson, we will be doing the factor theory. That's the next one, and then after that, the remainder theory. Okay, so two more with the polynomials to go. Factor theory and the remainder theory is about the polynomials, and then the mathematical proof and the methods of proof. See you in the next video.